Hi, and welcome to the first lesson on section 2.5, which talks about rational functions. In this lesson, we're going to learn how to identify asymptotes of a function. And as you can see, we're looking at the function f of x equals x over x minus 1, which I have graphed below. And when we're referring to asymptotes, we're talking about these imaginary red lines that aren't actually part of the function, but they tell us where the graph approaches. But notice the graph never crosses the line or touches the line. And on either side, it approaches but never crosses. So, what we want to do is first, before we identify the horizontal and vertical asymptotes, the first thing we want to do is find the domain of this function. And in this case, we have a denominator of x minus 1. So we want to do whatever causes that denominator to be a number other than 0. And that would be our domain. So in order to figure out what x can't be, we'll set x minus 1 equal to 0. So this tells us that x cannot be 1 because that would give me a denominator of 0, which we cannot divide by. So um, what this could be when we look at the domain, uh, this x equals 1, we want to test this to see if it's actually a vertical asymptote. And we can tell from the picture that it is because as we approach it from the left side, the graph approaches but never touches it. And the same happens as we approach it from the right side. So let's look at how we would do this mathematically. Um, what we would have is we have that 1 in the middle, and we want to look at what's happening from the left and from the right. So numbers like 0.9, 0.99, and 0.999 all approach 1 from the left. So if we have effectively set x equal to those values, we can figure out what f of x would be in each case. So when I put 0.9 divided by 0.9 minus 1, if you're doing that on your calculator, don't forget to put the denominator in parentheses. We get negative 9. When I do the same with 0.99 divided by 0.99 minus 1, I get negative 99. And as you can imagine, I'm going to get negative 999 when I put in 0.999. Now, if we look at numbers that are just bigger than 1, so such as 1.1 or 1.01 or 1.001, getting closer to 1 from the right side, if I put 1.1 in my calculator over 1.1 minus 1, I get 11. And if I put 1.01, I get 101. And if I put a 1.001 in, I get 1001. So as you can see, as I come into 1 from the left, my f of x approaches negative infinity. The numbers are getting larger and larger in the negative direction, just like my graph shows. And as I approach 1 from the right side, notice my numbers approach positive infinity, just like the graph shows. So because on either side of the line x minus 1, I'm approaching an infinity, that tells me that x equals 1 is an asymptote. So first of all, we have a vertical asymptote at the line x equals 1. And now we're going to look at where the horizontal asymptotes are going to be. So you saw our method for finding the vertical asymptotes was to look at anywhere it might affect the domain, uh, where you would get 0 in the denominator. Now, in the horizontal direction, in other words, to find horizontal asymptotes, what we're going to do is just check out the behavior of the graph as it approaches negative infinity and also as x approaches positive infinity. So when we're approaching negative infinity, we can set x values such as 10, 100, 1,000, 10,000, etc. You kind of get the idea. And then we'll look at what happens to f of x. If I put 10 in, I get 1.11. If I put 100 in, I get 1.01. If I put 1,000 in, I get 1.001, and you kind of get the idea. 10,000 is going to give me 1.0001. So clearly, it appears that the graph, as we go to negative infinity, seems to approach 1. This line f of x equals 1. And if we look from on the right side, as I go out towards, or I'm sorry, this was as I'm going out toward positive infinity, but now we're going to look at the left side as I'm going towards negative infinity. So if I put in numbers like negative 10, negative 100, negative 1,000, negative 10,000, we'll see what f of x does in that direction. So if I put negative 10 over negative 10 minus 1, so negative 11, I get 0.909. If I put negative 100 over negative 101, I get 0.990. If I put negative 1,000 in over negative 1,001, I get 0.999. And then you can probably guess I'll get 0.999, etc. It also looks that from beneath, f of x is approaching 1 as well. And as you can see from the graph, when I get lower and lower in negative values, the function does in fact approach 1. So I would say I have a horizontal asymptote at y equals 1. So let's look at another example. Here we have a little more complicated of a function, 4x squared plus 3 over 2x squared plus 1. And then again, we're going to look for the domain, and by seeing where the denominator equals 0. So I have 2x squared plus 1 equals 0. So 2x squared equals negative 1, and x squared equals negative 1/2. Well, there's no real number that would satisfy that equation. So as far as we're concerned, the domain of x is all real numbers. So in that case, it appears that there would be no vertical asymptotes. So let's go ahead and investigate for the horizontal ones. So what I'm going to do is I'm going to do the same thing we did before and check out what happens as I approach very, very large negative numbers for my x values, and also what happens as I approach very large positive numbers. So I'll do that on this side. So let's go with negatives. We can say negative 100, negative 1,000, negative 10,000. Should give us a pretty good idea. So we have 100 and 1,000 and 10,000 on the right side as well. So when I put that into my calculator, I get negative 100 squared. It is 10,000 times 4 is 40,000. So 40,003 when I'm putting it into this function. And on the bottom, I get 20,001. So 40,003 divided by 20,001 is 2.00. And since it's squared, it'd be the same thing for the positive side as well, 2.00. I think you're going to kind of see that happen here as we get bigger and bigger. The numbers are going to be 4 times something very large over 2 times something similarly large. You're going to find that these large numbers are going to keep giving you 2 over and over again. So that clearly shows us, just by putting that number into the function, just by putting these test x values into our function, we were able to figure out that we have a clear horizontal asymptote at y equals 2. And that time we did it without the graph, but if we really wanted to, we could bring in the graph. And as you can see, as x goes infinity to the left, you've got an asymptote at 2, and the same as it goes to the right. So go ahead and try this example question. We've got k of x equals 5x plus 10 over x minus 4. Figure out what that domain would be, and figure out where your vertical asymptotes and horizontal asymptotes would lie. It'd be nice if you could try this mathematically, but if you need to check it using the graph on your calculator, you can do that as well.